finished on Wednesday, I finished on congruent triangles, isn't that right? Okay, did I write down the sentence? How much has he written down? What was the last thing he wrote down? Congruent figures are said to be congruent if they are the same, something like that. Same size and shape, right? Okay, and that was as far as he got. Yeah. Right, okay. So I'm going to zone in on triangles now, okay? So congruent triangles. So I'm not talking about congruent shapes anymore. I'm talking about congruent triangles. So specifically a triangle, right? And I think I finished on yesterday, in a triangle, there are 6 measurements, agreed? There are 6 measurements. Sure. 6 measurements. Look, I ran out of room there. 6 measurements. That says measurements. And to prove 2 triangles are congruent, we have shortcuts. There is a choice. For shortcuts. So you don't have to take all 6 measurements from each triangle, right? Okay, so don't draw the triangles next. The next bit is just me explaining what I'm talking about. Well, trying to explain what I'm trying to talk about. Okay, so don't draw these triangles, just listen to me, okay? So, right, if I had two triangles, and I'm trying to say they're exactly the same, right? So that means everything about them is exactly the same. My point is, there's 6 measurements, so there would be the measurement of that side. So you'd have to measure that side and say it's equal to the measurement of that side, yeah? Then you'd have to measure that side and say it's equal to that side, okay? Then you'd have to measure this side and measure this side and show they're the same, okay? Then you'd have to measure this angle and show it's the same as this angle. You'd have to measure that angle and show it's the same as that angle, and finally you'd have to measure this angle and show it's the same as this angle. So 6 measurements, so you'd actually have to do 12, wouldn't you? You'd have to measure 6 things in here and 6 things in here. But there's shortcuts. You don't have to do all 6, okay, to prove they're the same. So there's a choice of 4 shortcuts, okay? So I'm going to explain each of the 4 shortcuts, and then we're going to look at how it works, right? Okay, so the first shortcut is side, 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 right? So there's 4 shortcuts. So number 1, it's called side, side. You can write this bit down now. Side. And we say S, S, S for short. So, for example, and you can draw down this example. Here's this triangle. Here's another triangle. I'm trying to prove they're the exact same. So I wouldn't have to measure any angles, right? I'd only have to measure the side. So if I proved that side was the same as that side, if I could prove that side measures the same as this side, and I could prove this side was equal to this side, then I wouldn't have to measure any angles, right? It's not possible for those triangles to be different. They have to be the same, okay? So I don't have to do 6 measurements in each. I only have to do 3 in each. Agreed? Okay, it's a shortcut. So if you can prove all 3 sides are equal, right, it's the triangles are exactly the same. Okay, right? Can I move? Can I go? Is that gone? Right, the second shortcut is I could do side, angle, side. So what will I call that for short? SAS. Okay, so if I have 2 triangles, oh sorry, there's a condition attached to this, right? And the condition is the angle must be between the 2 sides. Be between the 2 sides. That's what we put. That's why we put the A in the middle and don't spell S, ASS. We put the A in the middle because the angle has to be between the 2 sides. Because I could have spelt it angle side side ASS, and that would be way more fun. But the angle has to be in the middle. Is that okay? So that's why we went with SAS, right? So again, I have 2 triangles. Okay, and I'm trying to prove they're congruent. Okay, so do I have to make all 6 measurements? No, I can make 3 in each triangle. So I could measure this side and say it's equal to this side. I could measure this side and say it's equal to this side, and then I could measure this angle. See the way it's between the 2 sides? Right, it has to be the angle between the 2 sides. If I can say that much is equal, everything is equal. Right, I don't need to measure anything else because everything else has to be the same. Okay, is that right? Now, I'm just going to draw one where you can say, right, but don't bother drawing the next one. This is just me talking. So if I had a triangle like this, and a triangle here, and I measured this side, and I said it was the same as this. I measured this side, and I said it was the same as this. And then I measured this angle, and it turned out to be the same as that angle, right? Can I say those triangles are exactly the same? No, right? Because it doesn't fit the rule. It has to be side, angle, side. So it has to be side, the angle in the middle, and another side. Okay, is that all right? It doesn't matter which side. So if I say I measured this side and it's equal to that side, and I measured this side and it's equal to that side, then I'd have to measure the angle in the middle. So it has to be that angle has to be equal to that angle. Is that right? So it doesn't matter which 2 sides, but the angle has to be between them, right? And if it's not, you can't conclude they're the same. Okay, is that right? Next one, number 3, is angle, side, angle. What I call this for short? ASA. Okay, so this is angle, side, angle. Now there's no condition. This is the only one that has a condition. So it can be any 2 angles and any single side. It doesn't have to be between the 2 angles. Is that alright? So there's no condition. This is the only one where the angle must be between the 2 sides. But you might think here that the side has to be between the 2 angles, and it actually doesn't. Right? Is that okay? It's just, it makes a nice little ASA. It's easier to remember that way. Okay? So I have a triangle. And then if I have another triangle, and I'm trying to prove they're congruent, so I'll measure this side and it's equal to this side, right? I measured this angle and it's equal to this angle. I measured this angle and it's equal to this angle. So I have 2 angles and a side, so I'm done. I don't need to measure anymore because I know those, it's not possible for those triangles to be different. They are exactly the same. They are congruent. Is that right? So it's a shortcut. Are we all okay? Yeah. Right. Okay. And finally, the last one is specific to a right angle triangle. Right. So number 4 is the right angle. So I have to prove there's a right angle in each triangle. Right. I have to prove the hypotenuse, right, is the same measures the same in each triangle, and then any other side, okay. And I'm going to call this, what will I call this for short? RHS. Is that okay? RHS. So this is specific to right angle triangles, obviously. So if I have a triangle here with a right angle in it, and I have a triangle, I'll draw it backwards just to be different. A triangle here with a right angle in it, and I'm trying to prove they're the same. So the right angle equals a right angle. So if I measure the hypotenuse and measure the hypotenuse over there, and they turn out to be the same, and any other side, so I have a choice of any other side, so I can measure either one of either two sides. So if I measure this one and it's the same as that one, those two triangles are congruent because of RHS. Okay, and you'll be using those shortcuts, SSS, because they'll say, are these triangles congruent, right? And then they'll ask you why, right? And you can say SSS, SAS, ASA, RHS. They're valid, right, abbreviations in maths. All mathematicians know what they stand for. Okay? Is that right? So you don't have to write out the words. Okay? Right. Example. Example. Right. Okay. And my question is, are these triangles congruent? Are these congruent? Remember, congruent means the same, exactly the same. And you have to say whether they are congruent or not, and then you need to say why. Okay, so are they congruent? Are they exactly the same? So we have an angle and an angle. So we've one angle equal, don't we? You aware? Right. You've a length here and a length here, yeah? So you've one side equal. So we've one angle equal, we've one side equal, and then we've a second side, don't we? So we've two sides and an angle. That's the one with the condition. Is the angle between the two sides? Yeah. So are these congruent? Here's your answer. Yes, they are. And then they ask me for why. Look what I'm going to write. SAS. Done.
The second angle 36 or 30?
Sorry? 36. They're both 36. Sorry. 36 degrees. That's supposed to be a little degree sign up there. Sorry. Okay. 36 degrees. Okay. Are we okay? So the question is, are these congruent? And the answer is yes, they are. They're exactly the same. Why? SAS. Side, angle, side. Done. Okay? Right? Okay, example 2. Okay. Can move it up. Example 2. So that was a simple one. Okay, I'm going to go something a little bit harder now. Okay, so here we go. What do those arrows mean? They're parallel, doesn't it? So once they're parallel, what have we got? What letter do we write if they're parallel? Z's, right? Okay, and F's, right? Okay, if we can. So these are two triangles, B, E, A, B, C, and D. Okay, that's the way it's labelled. And it says AB, the length of AB.
Excuse me, please. Would Aisling, Amorim, Breed 1 come to reception now, please?
So they're telling me that AB is parallel to DC, but it also measures the same length. That's what two straight lines either side of the... Is that us? No, panic. Right, that's what the straight lines either side of the letters mean. Right? Okay, so the straight lines mean the length of from A to B is equal to the length of D to C. Yes?
And what's in between B and C?
Here?
Yeah.
E. Sorry. I just get excited. I start writing funny. Right? And the question is, prove that triangles Right, prove that triangles AEB and triangle DEC are congruent, okay? So I'm just going to draw a blue outline around triangle AEB. So it's A to E to B and back to the start. That's the blue triangle, right? Okay, is that right? And then I'm trying to prove that is exactly the same, it's congruent to triangle DEC, so D to E to C and back to the start, to the green triangle. Is that okay? So I'm trying to prove that the blue triangle is equal to is the exact same as the green triangle. Okay? So I'm going to have to write down, so what I'm going to do is I'm going to put triangle AEB here, and I'm going to put triangle DEC over here. Sorry, triangle DEC over here. And I'm going to make a list of all the things that are equal. So I'm going to pick one thing in this triangle and say it's equal to another thing in this triangle. Now I don't know, am I going to go down the route of SSS, SAS, ASA, or HS? I don't know what way I'm going to go yet. Okay, is that alright? So I'm just going to pick things in each triangle and just let them equal, and I'm going to end up with a big long list, and then I'll try and figure out, have I enough to say they're congruent? Okay, so can anyone pick anything in the blue triangle? Pick anything in the blue triangle that's the same as something in the green triangle. The angle or the line AB is equal to the line GC. Yeah, they're parallel, but that's going to tell us something else now in a minute. How do I know this is true? Because they told me. They told me it, didn't they? Right, okay. Now, the parallel lines has to come into it, because they wouldn't tell me about the parallel lines if they didn't want me to use it. So anytime I have parallel lines, I can draw that what? Z, can't I? So look, if I drew a Z, it's a sideways Z. See it? Now, it's going up here, down here, up there. So the Z I'm drawing is like that. Do you see it? So that means this angle in here would be equal to this angle in here, wouldn't it? Yeah, so that's this angle here is equal to this angle here. Okay? Right, now I have to name my angles properly. So I'm going to, how will I name this properly? Using the 3 letters, you know, right? Okay, I'm not. Now, if you're not good at naming them properly, you could put a 1 and 2 in each angle and say angle 1 equals angle 2. But we're going to name them properly because we're good at it. So what are we going to call it? Angle what? What's this angle called? Name it. It's at B, but to use the 3-letter name to name it. ABE. Very good. ABE. So it's at B and it goes from A to B to E. You name the letters around it. Right, that's equal to this angle over here. I said it was equal to this angle over here. What do I call that? DCE, yeah. DCE. I could have called it ECD as well, couldn't I? Right, okay, so as long as the C is in the middle. Right, and how do I know that's true? Because they're alternate angles. Alternate angles, and if you can't remember alternate angles, you just stick in the Z, right? So just draw a Z like that. Okay, is that right? Are we good? So you have to say something that's true and then you say why it's true. Now to pick something else, right? Okay, so can anyone name anything else that's the same? The angles here. See this angle? It would be equal to this angle. Why would it be equal to that angle? Vertically opposite, aren't they? Okay, so let's name that one properly. What do I call it? A, E, B. Yeah? So it's at E, so A to E to B. Yeah? Is equal to this angle over here. What do I call that one? CED. Angle CED, and why are they equal? Because they're vertically opposite. And if you can't remember vertically opposite, what letter will I write? What letter will I write for vertically opposite? An X, isn't it? Is that okay? Right, are we good with that? Okay, have I enough for any of the conditions? So I have a side, an angle and an angle. Have I enough for the conditions? Yeah, well, which rule, which condition? Yeah, so the triangles are congruent cause of ASA are congruent, and look, all I have to write down is ASA, right? Okay, so do you see how it's done? You have to pick out one thing in one triangle equal to another thing, and then just list everything that's equal and then see what jumps out at you, right? Okay, so I started listing. When I had 3 things done, I gave a check. Now if I didn't have enough, I'd have to keep going, see is there more things equal, right? Okay, but remember, every time you see parallel lines, girls, you can do the Z. Every time you see parallel lines, you can do the Z. I could have done the Z the other way. Look, there's a Z going that way as well, isn't there? Look at it. See it? See it? So I could have said that one was equal to that one, but I didn't need it. That one is equal to that one, but I didn't need to because I had enough information. Is that right? Okay, they're hard enough now, these questions, but if you remember the 4 conditions, tell me the 4 conditions please again. SSS, SAS, ASA and RHS. Right, so you need to, sorry? Yeah, right, okay. So you need to remember those, the SSS, SAS, ASA, RHS. You have to put it in there. It's not going to jump in. They're just random letters if you don't know what you're talking about. So you need to put it in there. So will you put it in there, please? Right, okay. So I'm going to ask you to do a few of these, right, over the weekend, right? Now, let's do page 181 to 182. Let's do 1 to 12, but let's just do the odd numbers. Okay, so 1 to 12, but only do the odd numbers. So 1, 3, 5, 7, I shouldn't have to tell you, but it's 1, 3, 5, 7, 9, 11, yeah? Is that okay? Right, okay, which isn't too much, because I know you'd be flat out studying, right, okay? Right? I'm right, aren't I? You will be? Yeah? Flat out studying maths? Yeah, no. I know.